So for this series, we need to identify a convergence test. If necessary, explain how to simplify or rewrite the series before applying the convergence test. You do not need to carry out the convergence test. So this is our task for this series. And then let's see what we can do here. So first of all, let's consider two terms of this series. So for example, some term a of k is equal to 100 to the power of k over k factorial times k squared. Well, now let's see how the next term will look like. So a of k plus 1. It would be equal to 100 over k plus 1, 100 to the power of k plus 1 over k plus 1 factorial times k plus 1 to the second power. Well, let's rewrite it. So it would be 100 to the power of k times 100 over k plus 1 times k factorial times k plus 1 squared. Well, now let's use the ratio test here. Let's see how we can use this kind of test here. So 1 over L is equal to limit where k approaches infinity. So wait, I'll write it down by ratio test. Where k approaches infinity of a of k plus 1 over a of k. Well, let's substitute the terms that we have just found. So it's equal to the limit where k approaches infinity, absolute value of 100 to the power of k times 100 over k plus 1 times k factorial times k plus 1 squared. Well, and this whole thing is over 100 to the power of k over k factorial times k squared. Well, now we need to simplify this whole thing. First of all, there are a few things which we can cancel out. We can cancel out 100 to the power of k. Then we can cancel out k factorial. And let's see what we get. So we get 100 the limit where k approaches infinity of 100 over k plus 1 cubed times k squared So let's write it again. So it's limit of where k approaches infinity. Here we have 100 times k squared, and here we can just take k out of our parentheses. So we will have k squared times 1 plus 1 over k cubed. So k cubed times 1 plus 1 over k cubed. Now let's just cancel out our k's. So here we'll have it like this, and we get our answer. So limit where k approaches infinity of 100 over k times 1 plus 1 over k cubed. We can see that this is definitely equal to infinity. This is equal to infinity, which means that 1 over L is equal to infinity. That means that L is equal to 0. And thus we can make a conclusion that our series converges. So our initial series is convergent.